Hi everybody and welcome to Metro Ethernet Talk. My name is Vasily Mukin. I am Solution Architect at the Juniper Networks. Within the course of today's session, I show you how to enable E-LAN service in MPLS network with Juniper Networks routers. VPLS becomes an obvious choice for this type of virtual connection in MPLS network. By itself, VPLS is supported in Junos quite for a long time, and there are certain different ways how it can be configured. Our today focuses on E-LAN connection between ACX5K and MX series router with enabled CV-LAN bundling and essentially service compliancy with MEF spec. E-LAN AVC usually interconnects uniports, or more precisely logical endpoints located at uniports of two or more metro nodes. Ingress frame is classified at uni based on a customer's PCP value and assigned a particular forwarding class. We saw how it works in Junos in our previous sessions. A VPLS header added to the frame at core-facing interface. A header contains VPLS label and X bit, which identifies EVC ID and cost priority of the frame in the virtual connection end-to-end. When frame arrives to the opposite side, access switch classifies frame based on X bit in the VPLS header, pops the VPLS header and sends packet out of uni. Overall intent of the today exercise is to enable Ethernet virtual private LAN connection between unis, allow EVC multiplexing, CV-LAN and customers' cost preservation, and CV-LAN bundling, which means multiple customers' VLAN tags will traverse an EVC end-to-end. I'm using a lab setup which worked for us when we talked about E-Access and E-Transit service flavors. Two routers are interconnected via MPLS fabric with pre-configured core-facing interfaces. As in the previous examples, we need to create endpoints of the EVC, enable connectivity and EVC control plane via Martini VPLS, assign course policies to endpoints. For the sake of brevity, we are not assigning any bandwidth profile. So let's have a look into configuration on both routers. On ACX5K, I'm going to use Uni XE0046 for our exercise. It is already configured with some endpoints we used before, which is absolutely okay to me and fits our requirement for EVC multiplexing. In Junos, flexible Ethernet services in conjunction with the flexible VLAN tagging configuration knobs are responsible for this attribute of the EVC. The configuration of a new endpoint or logical unit is very straightforward. I am assigning it with a right encapsulation and VLAN ID list, which corresponds to the list of CV-LANs. Now let's enable Martini VPLS routing instance. And we need to complete this task at both sides. Once completed, we can commit our configuration. The configuration committed successfully on MX, and we see on ACX, configuration hasn't passed a commit check. Specifically, ACX needs every bridge domain, including VPLS instance, to be normalized to a single VLAN, while our setup tries to send a list of CV-LANs. To achieve this, I'm going to follow recommendation given here and use a VLAN map to normalize my VPLS VLAN. Normalization in my case is provided by a simple VLAN push operation at EVC endpoint. I am pushing an additional VLAN tag on top of the customer VLAN list. I am also referencing this outer tag as an S tag. Now let's try to commit configuration once again. And it seems we are good now, just need to change configuration on MX side respectively. By the way, there is a certain amount of ways how VLAN tag can be normalized in Junos. For example, you can use VLAN swap operation or assign VPLS instance with a dedicated VLAN ID so that header of every frame which enters instance is rewritten with a given VLAN ID number. But all these methods change the original customer C tag as well as break an original course marking, which will be very tricky to restore once delivered to remote endpoint. Pushing additional VLAN tag on top is simple and effective way of normalization, which allows to establish a MEF compliant service. We are done with our connectivity part, and let's take care of course configuration. Core interfaces of the ACX router are already assigned with X-bit classifier and rewrite rules. On the ACX side, we have a PCP classifier also assigned at UNI interface XE0046. ACX router supports only one classifier assigned globally at the port level. This classifier acts on all logical units until some of the unit is assigned to a particular forwarding class. We saw how it works when we talked about E-Access and E-Transit service flavors. On the MX side, I am assigning C-tag PCP bit classifier to the newly created logical unit. Rewrite rule is not required here as we want to keep original course marking of the customer frame. One important thing to add to the MX configuration. Once a packet entering VPLS instance with no tunnel services not configured, it passes via a dynamically created LSI Logical Interface. LSI stands for a Label Switch Interface and is part of the Junos VPLS implementation. For example, if you execute Show VPLS Connection, you can see this interface present here. This interface allows to terminate pseudowire to a VPLS instance. Within a MX router up to 17.2 R1 Junos release, this is something I am using in my setup. This LSI interface by default is assigned with default classification rules, which is different from classification rules required for MEF compliant services. Specifically, mapping between the value of the PCP bit and loss priority is different. To overcome this default behavior, we need to explicitly configure VPLS routing instance with an appropriate class of service rules. At the last step of our exercise, let's send some traffic to EVC and make sure that right connectivity is there. I have 3 streams of traffic configured at Ixia traffic generator ports. Streams are configured to 3 different customers' VLAN ID and variety of PCP values. 500 packets are sent per stream in each direction. Now I'm starting the streams. All packets are delivered without losses. On the MX side, I am receiving customer frames with unchanged C tags and original PCP bits. And same picture we can see at ACX side. S tag is pushed at ingress UNI and popped at egress, so we obviously do not see it here. We're all set for now. There are just 2 things to get out of today's talk. First, now you know how to normalize VPLS instance at ACX side when CVLAN bundling is required on E-LAN EVC, and second, how to enable calls inside the VPLS routing instance on a MX series router to make sure all frames are delivered with appropriate forwarding classes and loss priorities. At the next session, I'll continue talking about the VPLS on ACX5K series. We'll see if VPLS can be used as a universal approach to enable not only E-LAN but also E-Line connectivity. Thank you for staying with us and looking forward to meet you at next Metro Ethernet session.